Hello, this is Nick coming to you today with introductory Java language concepts. And with these, I'm just going to be doing about 30 problems, and they're all good reviews for the AP Computer Science test that's coming up in the next month or so. So, for this first question, just move straight into it. Which of the following pairs of declarations will cause an error message? And I suggest that you just pause it right here and figure out your answer, and then I will go on with my answer. So, what you want to remember here for my explanation is that you can only fit so much into a certain unit. So in an integer, you have a signed integer with 32 bits of information. And a double has a lot more than that. So definitely a double can't fit in just straight into an integer. And so with number 1, there's a problem because you're trying to put 14.7 into an integer, and that just won't fit. For number 2, the integer is casted as an int, so that fits in just fine because you are saying to the compiler, yes, I know that I'm going to lose some data here, but it's all right with me. And then with 3, you have an integer, and it's going into a double. So a double is a bigger package, and int is a smaller package. The smaller package fits in the bigger package, as it were. So the answer for that one is B. Moving on to number 2, what output will be produced by system.out.print? And that's pretty hard to write, pretty hard to read, that is. So just pause here. And my answer is E, because the second backslash, as you can see right here, oh, there we go, right there, is escaped by the first backslash. And so you only end up with one backslash. And then this asterisk, nothing is done to it, because these backslashes have already acted on one another. So nothing happens with this backslash, this asterisk. And then we go on into the middle of the little sentence, the backslash n, and this is known as an n-line, as I'm sure you all know. This basically puts in a carriage return. So any of the ones that don't have a carriage return are definitely wrong. So A and B, wrong. They're just trying to trick you. So then in the end of the sentence, we have another backslash escaped. And with this, we definitely know that it's E, because there's only one backslash and there's a carriage return. So there you go. My number 3. So for this one, you refer to the following codes fragment, the double answer 13 divided by 5, and system.out.println 13 divided by 5 equals, and then you add in the answer. You concatenate that answer. So the output is 13 divided by 5 equals 2.0. But that's not exactly what you expect. You expect a 2.6 maybe, if you're not as familiar with the whole concept of integer division. So the problem with this is that it's interpreting 13 and 5 right here as integers. And so integers divide in a special way where they divide and then they are instantly, the decimal place is just stripped off. So you only look at the at before the decimal place, and then it's put into a double, so a 0.0 is added, and you only end up with 2.0. So the thing that you need to do is either cast or divide with a double, which is 13.0, 5.0. Now, E is not doing either one of those things. It's dividing 13 by 5 and then casting that to a double, which will get you this exact same result, because that's basically already happening. It's 13 divided by 5, and then it's going into a double casing. Right here, it's 13 divided by 5, and then you're changing it into a double, which is basically the same thing. So there you go. It's definitely E. For number 4, we have what value is stored in result if int result equals 13 minus 3 times 6 divided by 4 mod 3. So this is almost a test of whether you can follow order of operations. So it's a pretty easy question, I'll give you that. So first you just go through this, 3 times 6, and then divide by 4, mod by 3, and then 13 minus all of this. So 3 times 6 is 18, and then you divide by 4. Mod 3 is 1, because when you divide 4 by 3, you have a remainder of 1. And then you do 13 minus all of that, which is 12, which is E. Seems like all the answers are E. Excellent. So we have a little bit of a skip here. We have number 6. Let x be a variable of type double that is positive. A program contains the Boolean expression math.pow x 0.5, so that's just x to the 0.5 power, is equal to, that's equality, math.square root of x. So that's this, and this should be power. So even though x to the 1/2 is mathematically equivalent to square root of x, the above expression returns the value false in a student's program. That seems kind of weird, right? Which of the following is the most likely reason? Now, I came into this with I didn't really know about that. I didn't really know that that would happen. But with the answer choices they give you, it's actually pretty easy to guess. So math.pow returns an int while math.square root returns a double. That's, I mean, that just seems kind of silly to me, because a power and square root, I feel like they'd both be the same type, because often with square roots you'd return an integer, maybe a double, and with power you might get an integer, you might get a double. So you'd want to have the biggest available thing, so you'd have a double. So that's not right. So B, x was imprecisely calculated in a previous program statement. That's kind of just passing the buck, so it's not right. C, the computer stores floating point numbers with 32-bit words, which that's only right for integers, and its words isn't right. So that's wrong. With D, there is round-off error in calculating the pow and square root functions. This is the right answer. So with these kinds of equations, it's difficult to get a definitive answer without rounding off at some point, because they are computers. So they might have one less decimal point here, one more decimal point here, or round at different places, and then they don't equal each other. And then there's overflow error in calculating the pow function, and no. So moving right along.